A serious nag has arisen in the field of astronomy due to the latest findings of the James Webb Telescope, which have illuminated previously unknown aspects of our universe. The continued discoveries of this telescope are having a profound impact on our understanding of the universe. The telescope, by casting its gaze into the remote past, revealed secrets that were previously beyond our perspective ability. A recent surprising discovery has challenged our fundamental understanding of the universe, indicating that we may be completely wrong about its size. In a recent paper, scientists have exposed that new images captured by the Webb telescope have identified objects that existed only 120 million years after the Big Bang. This not only challenges what was previously believed, but also calls into question the foundations of the standard cosmological model. Astronomers admit they did not anticipate discovering something of this nature in the images captured by the Webb telescope. It appears that the universe is indeed old, but not infinitely old, a revelation that has surprised many, refuting the idea that the universe must have an infinite age without a starting point. This discovery has shown that our intuition has been wrong most of the time. We face the uncertainty of not knowing what else the universe has in store for us. Even when the Webb telescope looks as far out into space as possible, it only manages to observe a distance of about 46.5 billion years. The radius of the universe we can observe, known as the Hubble radius or Hubble sphere, defines the limit of what we are able to see from Earth. The most remote galaxy discovered so far, the IES galaxy identified by the Webb telescope, lies within this region. The Massey galaxy, the most distant galaxy found so far, existed approximately 450 million years after the Big Bang and also lies within this Hubble sphere. While we know that our universe is expanding, what is even more intriguing is that this expansion is accelerating. As the universe expands, the Hubble sphere grows, allowing the visibility of objects beyond its boundaries. However, at the edges of the sphere, the expansion is happening faster than the speed of light. This means that although the Hubble region does not expand, when we observe extremely distant objects, the speed of expansion of the space between us and those objects exceeds the speed at which the light emitted by them can reach us. Therefore, light from very distant stars and galaxies is moving away from us at a faster rate than it can reach, due to the stretching of space between us and those distant objects caused by cosmic expansion. The Hubble sphere will stop growing once it reaches the limit of the cosmic horizon, thus defining what is known as the observable universe, a region that shows us the maximum extent of our vision within the universe. The observable universe is like an imaginary sphere that surrounds us and has a diameter of approximately 93 billion light years. This measurement represents the maximum distance to which we can see galaxies and stars. Light coming from within the sphere has had to travel for a considerable time to reach us. However, anything beyond the sphere will not be visible to us, even if we were to use the most powerful telescope imaginable. The reason is that the light emitted by these objects has not yet reached us. This situation raises an interesting question about the total size of the universe outside the limits of our observable sphere, and in reality, we do not have a precise answer to this question. Although our current cosmological theories have provided mathematical estimates, we still lack sufficient information to be certain. We may never be certain. It has been estimated that the entire universe is at least 250 times larger than what we can observe. Some research has suggested that the total size of the universe could be astronomically enormous, with estimates that it could be on the order of 10 to the power 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 of 10 to the 122 times larger than our observable universe. This number is incredibly large, with an enormous number of digits. Despite these estimates, the uniform distribution of matter in the universe and the uniformity in the temperature of the cosmic microwave background suggest that our universe could be infinite in size, although this conclusion remains a theoretical possibility rather than an absolute certainty. When we look out into the extremely far distances in space, we are actually observing events that occurred a very long time ago. The galaxies we see near the Hubble sphere are not galaxies that exist in the present, but are galaxies that existed billions of years ago, according to our standard cosmological model. According to this model, approximately 14 billion years ago, the observable universe and everything beyond it would have been concentrated into an extremely small point, which we called a singularity. However, this notion of a singularity compressed into an infinitesimal point would be true if the universe were infinite. However, the evidence points to the universe being infinite, suggesting that it was always so, without a singular beginning. This would imply that the Big Bang occurred everywhere, meaning that the first galaxies did not form in a particular place in space, but formed everywhere in the universe, even beyond what we can observe. This idea raises the question of the starting point of the event that started it all. This question transcends science and enters the realm of philosophy. It is similar to the old steady-state model that held the idea that the universe has always existed without a beginning. This perspective was appreciated by figures such as Newton and Einstein, who believed in a universe that had always been there, without a beginning. Einstein initially rejected the idea of the Big Bang, but mathematical evidence led him to consider the possibility of a finite origin. Observation of cosmic microwaves throughout the universe suggests that the singularity is not the starting point from which everything emerged, but rather an infinite place where all matter, everywhere in the universe, came into existence approximately 13.8 billion years ago. So far, what I've mentioned explains the enigmatic nature of our universe. However, new discoveries from the Webb telescope are challenging the estimated age of the universe. Each deep image captured by the Webb telescope reveals unexpected surprises that force us to reconsider the conventional Big Bang model, which stipulates that our universe is approximately 13.8 billion years old. Until 2022, the most distant galaxy known was believed to be Sirius 93-316, but later studies revealed that it was that nearby galaxy that appeared more distant due to dust clouds. Recently, the James Webb Telescope has discovered the galaxy F200DV045, a high redshift galaxy candidate with an approximate value of Z20.4. which corresponds to about 168 million years after the Big Bang. If confirmed, this would be one of the oldest and most distant galaxies observed. This discovery, although it still needs to be confirmed with further tests, may require a revision of the standard model to obtain a better estimate of the age of the universe. In addition, massive galaxies have been discovered that apparently formed a few million years after the Big Bang, challenging our current understanding of how quickly galaxies formed in the early universe. Another significant finding was made with the help of the James Webb Telescope, revealing the presence of two black holes 700 million years after the Big Bang. This discovery suggests that the universe may be much older than previously thought, or possibly had no absolute beginning and has always existed. These revelations open up the possibility that the universe, seemingly infinite in size, may also have an infinite age. The Big Bang could have been just a moment in the evolution of this universe without a true beginning. However, more research will be needed to determine whether this idea of an external universe without a beginning aligns with our current scientific theories to effectively explain the unfolding of events during the Big Bang. This here concludes the thought on this current crisis in cosmology. Feel free to share your thoughts in the comments box. Remember to like and subscribe, and I'll see you in the next one. Thank you so much for watching.